Hi, welcome to another video. This will be our second lesson on the volume of a prism. Remember, the volume is the amount of space inside a three-dimensional object. You might recognize this building as one of the most famous prisms ever built. It is the Roman Colosseum. Remember, a prism is a mathematical shape that has a cross-section that extends along a depth. We have circular prisms, triangular prisms, trapezium prisms, hexagonal prisms, and many different other types of prisms. In this video, we're going to focus on a cylinder or a circular prism. Cylinder is a prism that has a circle cross-section that extends along a height. We'll add in some hidden lines, and you can see that cross-section is a circle. Although it looks like an ellipse or an oval, that's because we've drawn it that way. The cross-section, the circle, extends all the way down the height and remains a circle all the way throughout the cylinder. We have a radius and we have a height. Right, you remember the volume of a prism from our last lesson is equal to the area of the cross-section times the depth. But because we're focused on a cylinder, we're going to stand it up and we're going to use the formula volume is equal to area of cross-section times the height. The height is the same as the depth. Right, example 1. Calculate the volume of the following cylinder. You'll see that the radius is 8 and the height is 15. So the volume is equal to the area of the cross-section multiplied by the height. Well, the cross-section is a circle, so we're going to have volume is equal to pi times radius squared, which is the area of a circle, and we multiply that by the height. So the cross-section area is pi r squared, and we times that by the height. So the volume is equal to pi times 8 squared, because 8 is the radius, and we multiply that by the height of 15. Let me grab my calculator. Pi times 8 squared times 15 gives 3015.928947, and I'm going to round that sensibly to 3015.9 centimeters cubed. Remember, volume is measured in cubed, and I've rounded that to 1 decimal place. What does that tell me? If I had a small cube that's 1 centimeter by 1 centimeter by 1 centimeter, I would need 3015.9 of these small cubes to make up the same space as my cylinder. Example number 2. Calculate the volume of the following cylinder. Notice we've got the diameter of 1.4 meters this time, and the height is 3.26 meters. So the volume is equal to the area of the cross-section times height. Well, the cross-section is a circle, so the volume is equal to pi times radius squared. Multiply that by the height. Remember, the cross-section is a circle, which has the area pi r squared, and we're multiplying that by the height. But because we have the diameter of 1.4, we need to take the diameter and divide it by 2 to get the radius. So the radius is equal to 0.7 meters, because the area of a circle needs a radius. So the volume is equal to pi times 0.7 squared times the height, which is 3.26. Grabbing my calculator and calculating it, I get an answer of 5.018380105. I'm going to round that to 5.02 meters cubed, and I've chosen to round that to 2 decimal places. Again, I'd need a large cube of 1 meter by 1 meter by 1 meter, and this cylinder would take up just over 5.02 of these big cubes. Great, thank you very much for watching.